Okay, so my presentation is on turbine engines, and this here's a Black Hawk helicopter, and it has two turbine engines. And I worked on these for 8 years, and I hold an FAA power plant license. And but that airframe and power plant, that covers the whole aircraft. A very small amount of my job was to work on engines, because turbine engines are, believe it or not, very reliable, and they hardly ever break. But I did work on the engines for about 8 years as part of my job. So. The reason I find them so fascinating is because they put out so much horsepower from such a small amount of metal or machinery. So each one of these, according to Corpus Christi, each one of these engines produces about 2,000 shaft horsepower, and that's done by publication. I took that off a publication from 2004 on the Corpus Christi website. So 2,000 horsepower, and each Blackhawk has two engines. So you can see each one of these that look like ears right there. Those are nacelles. They house the engines. And these engines also are used in the Apache. These are Army helicopters here. So the things that will be covered are the primary differences between a turbine engine and a car engine, or the ways another thing that will be covered are the ways mechanical energy is extracted from a turbine engine, and see how a turbine engine works. Why this is applicable to everybody? Well, you may find this interesting and want to pursue a career in it, and because commercial airliners use turbine engines, and eventually you're going to use one to get you from one point to another. So this applies to everyone. First, let's talk about how a turbine engine differs from a car engine. So to do that, let's address what's a definition of a turbine engine. And the freedictionary.com classifies a turbine engine by three characteristics. A turbine engine uses internal combustion, a turbine engine has an air compressor, and a turbine engine uses combustion to turn a turbine. And this is different from a car engine, because a car engine typically uses combustion to drive a piston downward, and that's all the energy is extracted from the piston that turns a crankshaft. So this is just slightly different in a turbine engine. And a car engine is better for cars because we travel at different speeds on the road. A turbine engine runs typically at 1 RPM constantly and stays there. So when we come to a stop, if we had a turbine engine in our car, it would just stay at 9,000 RPM. It would be very hard to keep on the road, and that's why it's just not practical. Also, they're very loud, and they're not very fuel efficient, even the small ones. So, but a turbine engine is practical for the use in three areas, in aviation at least, and three ways mechanical work is extracted from a turbine engine is: one, the output shaft is connected by a gearbox to a gearbox, and this can be demonstrated right here. If you can see right there, there's a what is called a fairing, and that fairing covers up a shaft, and that shaft brings the power from the engine into a transmission right here that then translates that power into circular motion for the rotor head. And so that's one way. Another way power is extracted from a turbine engine is, let's see, where did I leave off? A prop plane. A prop plane also uses a gearbox, but this gearbox, instead of going through this whole intricate process right here, it's just one gearbox that would be mounted on the front, and a prop mounted on that, and it just kind of reduces the speed. So this engine here turns at 9,000 RPM. You would not want a prop to turn. It would not be very efficient to turn at 9,000 RPM. And this one turns, on a helicopter, turns about 300 RPM to 600 RPM. And a prop would probably be 600 to 900 RPM. But those are two ways. And the third way is through thrust. And we get thrust from a turbine engine by a series of baffles in the exhaust. And that's how a fighter jet works, and that's how a commercial airliner works, kind of. So those are the three ways. Now that you have a foundation on how mechanical energy is extracted, you might be asking how a turbine engine works. Well, it can be described here as if God were to come down and hand you a fan and tell you that this fan is indestructible, then the first thing I'd want to do is blow it up. So I'd take it outside and I'd mount it down to something very strong, and I'd put a stick of dynamite through it. So if we imagine this this concept of combustion, the dynamite representing combustion, and the fan, just a regular desk fan, representing a turbine. Where all these things in here, all these fans, all these little fingers off of there, those are all turbines. And so if you were to set that dynamite off in front of that fan, as the explosion were to travel through it, the fan would turn. And so this is constantly happening here. And as you can see, it's basically suck, squeeze, boom, blow. So it pulls in air through here. This right here is a thrust from the first stage. And you can also get thrust from the exhaust. But these smaller ones here represents air that's going to travel into a combustion chamber where fuel is introduced and combustion will take place, and that will go through another series of fans right here and be pushed out the exhaust. And so it's really simple. Suck, squeeze, boom, blow. Suck in through here. Squeeze it right here through the air compressor. As we remember, the definition of a turbine engine has an air compressor, which is this right here. And it's going to, so suck, squeeze, boom, so combustion takes place, and then exhaust, blow. And it's that simple. And it's pretty much a constant process. It's just constantly on fire right in here. Constant fire is taking place, and it's pushing through these fans, and it's just keeping these fans turning. And so that is just a very basic concept of how a turbine engine works. So just to go over some of the things that we covered, a turbine engine is different from a car engine. The applications of turbine engines, and of course there are more than just the three we discussed, and how a turbine engine works. And this is just a very basic understanding of how a turbine engine works. There's a lot more that goes in there, but honestly it's a lot easier than how the engine in your car works. There's a lot less moving parts. And just a closing thought, the strength of turbulence is proportional to the temperature of your coffee, which is Gunther's second law of air travel, and it kind of follows Murphy's law there. So.